Hi everyone, this is Team First Step, and the problem statement we chose is fake social media accounts and their detection. To define our problem, nowadays fake social media accounts are a growing menace which pose serious threats through impersonation, misinformation, and security risks. Our problem statement is proposed by the Indo-Tibetan Border Police, and even them and the Home Ministry lack an efficient or centralized system to address this issue. So, this is where our solution steps in. Team First Step has developed a groundbreaking system designed to combat these issues with real time precision, offering a centralized autonomous solution. The challenges we address are impersonation, as fake accounts pretending to be real users causes identity theft, fraud, and erode trust. These accounts play a crucial role in spreading false narratives and disinformation, and security risks can lead to phishing attacks, hacking attempts, and the exploitation of personal data. We proposed a solution where we first collect and authenticate user data. We collect data from the APIs from the Facebook Meta Developer website. Once we get the access to the API, we take that as our data input, and then we perform we perform feature engineering, which is to extract important features, that is which is contributing to saying that the account is fake or real. And then we take that features and build a model by performing various analysis techniques like AI behavioral analysis. For suppose it takes certain engagement metrics like activity patterns, which analyze posting frequency and interaction types. Because of normal account wouldn't post at a higher frequency, or it wouldn't post repetitive content like a bot account. Or we can look for unusual engagement patterns like excessive likes or comments from a smaller number of accounts. Or um, we can check for groups of accounts with similar suspicious behaviors using clustering algorithms. Then we perform AI image verification, using which we use cross reference, that is, we check against the Indo Tibetan Border Police's official channels for confirmed accounts. Or we check using metadata like file creation dates, follower counts, and profile consistency. Or look for unusual patterns in the profile creation or changes that might indicate fake activity. We perform network analysis, which includes checking or mapping relationships between accounts using graph databases or libraries like NetworkX to visualize clusters of fake accounts and analyze how accounts influence or amplify specific messages. Or we can also use community detection algorithms, like using Lewin method to identify groups that may be coordinating malicious activities. And then we created a dashboard which displays immutable risk scores and flagged accounts using blockchain technology. And at last, we use MFA authentication, that is multi factor authentication, which ensures that only authorized personnel can access final sensitive results, like using OTPs or biometrics, and then only giving authorization, or then only giving access to the website. So, the key features and benefits of is that it is cost effective, which is offering a low cost alternative to expensive AI systems, and technically reliable, with sophisticated AI algorithms continuously improving with each detection, and customer friendly with a simple, intuitive UI that law enforcement and social media platforms can use with ease. The most significant benefit is our ability to distinguish fake accounts from the real ones in real time. This is the game changer in preventing the spread of misinformation and safeguarding user security. And additionally, we provide a centralized agency, that is a dashboard which integrates directly into the platforms and eliminating the need for multiple external touch points and making the detection more smoother. Market for this is vast, with significant growth opportunities, especially in sectors focused on national security and cybersecurity. As there are over 3 billion active social media users globally, there is an urgent need to safeguard platforms against fake accounts, misinformation, and cyber attacks. Our solution's feasibility is supported by our use of AI and ML, which are easily scalable and adaptable to new platforms. The existing solutions are platforms like Facebook's deep text and Twitter's AI spam filters attempt to identify fake accounts but fall short in terms of adaptability, speed, and real time prevention. While they're useful, they don't offer the decentralized verification and community driven reporting that we bring with blockchain integration. We believe that customer engagement is very critical, and we have designed our system to encourage users also to participate in the detection process. Once we scale the product, we are going to create a co-creation model that ensures that the platform stays dynamic and constantly learning from user input and feedback. In our dashboard, firstly we have four sections, which is the dashboard, and then analyze account section, submit report, and settings section. Then when we click on analyze accounts, users can drop files or when we drop files and click on analyze account, it shows the analysis, and we can enter usernames into our dashboard if the account we have entered is fake or not. And then when we click on add account and analyze accounts, we can see that the username fake underscore user 123 is detected as fake, and then we can review it. And then so next we provide clear results through these pie charts and feature analysis, highlighting patterns like edge flow. So here we can see that real accounts percentage is less comparatively to the fake accounts, and it's just for the statistics. And feature analysis is to show which feature contributed the most to say that the account is fake or real. Here we can see that the edge underscore followed underscore by contributed the most to saying that the account is fake. And then we submit this report by clicking on the submit report button to the central agency for further review. And this is the model we have created. We have created this model using random forest classifier. We have uploaded a CSV file called underscore accounts.csv, and it's a dummy dataset from Kaggle. And then we printed accuracy classification report, and here we printed confusion matrix accuracy. And then here we can see that the accuracy is 0.93, which is very close to 1. That means the accuracy is very high. Since it's dummy data, the accuracy is showing high, or one or two values are predicted wrong, so it's showing almost 0.93 accuracy. And then feature importance, we can see that edge followed by follow has the more contribution. And then we also showed the data visualization using different types of plots, sorted using decision tree and also SHAP. Our business model focuses on a subscription based service for large organizations like social media platforms and law enforcement agencies. And for smaller business, they can utilize paper report services. And in terms of risk management and contingency planning, potential AI misclassifications we are mitigating through continuous model training and user feedback integration. And to ensure smooth adoption, our solution is designed to be easily integrable and customizable. For the next 2 to 3 years, we aim to scale our solution, ensuring widespread adoption and integration. We have conducted extensive research into the market size and user needs, so the solution fits perfectly into the cybersecurity and national security spaces, offering centralized management. What we want is to bring a solution to the next level. We are looking for partnerships with government bodies and social media platforms. Feedback is also very crucial to refine and perfect our solutions, because we are always here to learn, and we welcome any insights to further develop the technology.
So, in our hackathon project, the blockchain code ensures security, decentralized data storage using smart contracts. These contracts automate transactions and maintain a transparent, tamper proof record, ideal for decentralized apps. Let's walk through the code, how the code works, and setups the blockchain and handles the transaction. So, for executing the project, we followed certain steps. The first step includes deploying the smart contract. In order to deploy the smart contract, we have used this Remix RDI platform. In that Remix RDI platform, we need to create a file. And here we have created a file as fake account detection.solidity file. And here this is the solidity file, solidity code which we have extracted. So in order to run that solidity code, first we need to compile it. For compiling, we need to come to the solidity container, select the specific version of the compiler. Next, we need to compile and run the code. After compilation is done, Then we need to go for debugging and run transaction. Debugging and run transaction. Here also we need to select the suitable virtual machine environment. Here we have selected Remix virtual machine. Next, after selecting everything, we need to deploy. Once the code is deployed, the output is given as like this. From this output, we need to copy the contact address and also the ABI file, which is useful in the further Python script. The contact address is here. In order to get that ABI file, you need to go for this Solidity compiler, and here you can see the ABI file. Once you click the ABI file, you can copy to the clipboard. This is the ABI file which we have extracted from the Solidity code. Okay. So the second step includes running of the Python script. Before running the Python script, we need to install certain packages. So we have installed Web3 Pandas package. After the this is the installation. After the installation is done, we go for this Python script code. As already mentioned, the contact address should be pasted here, and here you will copy the path of the JSON file. Next step is loading the contract. We use the ethereum.contract to load the contract. Next, here the data we have used is through data frames. It contained two attributes, user ID and fake. For user ID, we have used 5 users, and for fake or not fake, we have given zeros and ones. 0 means real, 1 means fake. So the user 2 and user 4 are fake users. So let's check what will be the output. Once we run this, so in order to run this, we need Gashi. For Gashi installation, we need to set up the Node.js in our monitor. Once the Node.js is installed in our Windows, for checking that, we use the command prompt. We use node.v, node space v, and npm space v to check whether the Node.js is installed in our computers. So after that, we need to install the Ganeshi. Once it is installed, then you can connect the Ethereum with our code Python script. So this is the Python script. Once we have run the Python script, we get the output as like this. We get whether the user is registered and verified. So since already discussed, user 2 and user 4 both are fake users. So the code output is like this. User 1 is registered and verified. Since user 2 is fake, it is just registered but not verified. Thus similarly it goes for user 4. It is just registered but not verified. So this is the output of the code.
Finally, we team First Step are proud to present a path-breaking solution to the problem of fake social media accounts. With AI, blockchain, and real-time tracking, we have created a system that's effective, scalable, and ready for deployment. We invite you to join us in this journey, whether through partnerships, feedback, or support. Together, we aim to make social media a safer and more reliable place.